What I'm going to do today is show you how BigML is the premier cloud-based tool for turning data into actionable insights. Our easy-to-use interface hides the complexity of powerful machine learning algorithms in a cost-effective manner. Well, let's look at one of the reasons that our cloud-based approach is both easy to use and cost-effective by comparing it to locally installed tools. In order to get it started with local tools, you'll probably need at a minimum a server and perhaps a license, which you'll likely need to acquire from a vendor. Even if you don't need a license, you'll need to stay on top of upgrades to take advantage of new features. And of course, there'll always be patches to keep everything bug-free and secure. And if you have a lot of data, you'll need to manage storage. And when you need to scale, well, your troubles will scale as well. With all that to manage, you may need to add a sysadmin or two. With BigML's cloud-based approach, we have taken care of all the hard work. All you need for any size job is a modern browser. But just because BigML is easy to use does not mean it is less powerful. Instead, we have created a simple 5-step workflow for turning data into actionable insights. This well-defined workflow allows us to constantly innovate, exposing complex machine learning algorithms while maintaining an easy-to-use, consistent interface. Let's take a closer look. The first step in the workflow is to create a source by uploading your data to BigML. Data can be provided in various tabular formats, such as CSV, TSV, Excel files, ARC, etc., and can even be compressed. The uploading process itself can be done directly by a drag and drop, remote URL, S3 buckets, or even OData sources. Once uploaded, BigML will peek at the contents and try to guess the locale and field types, but you can override these settings in the source editor. Finally, from the source, you select the fields to include when building a dataset. In the BigML workflow, datasets are the fundamental objects for building models. It is more than just an intermediate step, however, as you can examine the distribution and univariate analysis of each field in the dataset viewer. The next step is to create a model. This requires selecting the objective, that is, the field we want to predict, and which fields to consider as inputs to the model. You may also configure advanced controls like sampling and pruning options. Once the model is built, you can begin gleaning insights directly from the tree view. This is a major strength of BigML. Decision trees are easy to understand, and BigML provides a beautiful visualization of the tree. You can also use filters to narrow down the search to specific outcomes, rare events, common events, or even filter by the confidence of the model. Another feature exclusive to BigML is the sunburst view, which provides a quick and informative overview of the entire model. It gets better. Another great feature of decision trees is that they are easy to represent as actionable code. So you can actually download your model as a Python function or Java or one of many other available options. And finally, you can share or even sell your model in our marketplace. But how do you know if your model is giving meaningful insights? To address that, BigML provides the ability to create an evaluation of your model, comparing predicted values to known values for withheld data or against a new data set that you provide. By examining traditional machine learning metrics, you can determine if your model is performing well. And you can compare evaluations side by side, which makes it easy to tell if changes you make to your model are improving the predictive power or not. The final step in the workflow, after iterating the previous steps and creating a model that's performing well, is to use the model to make predictions. While you can download your model and make predictions in your own environment, you can also make predictions using the BigML UI or through the API. All right, so now that we've taken a look at the BigML workflow, let's run a live demo. For this demonstration, we are going to use BigML to predict customer churn for a fictional telecom company. Understanding churn is important because customer acquisition can be expensive and time-consuming, so if there's a way to reduce churn, then it may improve revenue. Also, examining churn may reveal reasons, that is, deficiencies in your business model that could be addressed, leading to less churn. Here's a sample of the data that we will be analyzing. Each row represents a customer, and each column, also referred to as a feature, contains information about that customer, what kind of phone plan they have, information about usage, billing, how many calls they've made to customer service. The final column marked churn is a Boolean representing whether that customer maintained their account after the period in which the data was collected. So to summarize, we want to build a model that uses the features of each customer to predict whether or not they will churn. Let's get into this. So when you create an account with BigML and log in for the first time, it should look something like this. And you'll see these tabs across the top that nicely match the steps in the workflow that we just called out. And of course, we start from the first step, which is the source. So we need to get our telecom data into BigML, and I'm going to do that just by opening the file from my desktop here. And this will upload the file. And once it's uploaded, we can click on it and take a look at it in the viewer. Now, the first thing that I want to mention is that you'll notice the view is rotated 90 degrees. That is to say, the columns that were features before are now appearing as rows. This is something that we do in the interface just to make it easier to display data sets that could be very wide. That is, if you had thousands of features, it would be very inconvenient to try and scroll through them left and right like this. So we just rotate them 90 degrees, and then you can page through them using the controls down here. You'll also notice that the fields have been auto-typed. So this first field, which is the state, has been recognized as a categorical. The second field, which is the account, has been recognized as numeric. We'll talk about that again more in a second. And some of these other fields, like day, minute, day calls, are all typed as numeric. Now, the area code is kind of an interesting one. It's been recognized as numeric, but we could probably agree that there's not much to be gained by comparing area codes, whether they're less than or equal to each other. And so we might prefer this field to be categorical. Well, that's quite easy to do. We can come into the source, edit mode, and all we need to do is update the detection to categorical, and our source will now have the area code as a category. Now, I want to call out one of our new features for our fall 2013 release, which is something we call inline field editing. Now, this field down here has a lot of abbreviations in it and could potentially be confusing about what this actually means. So what we can do is we can click here and we can actually add an annotation directly to the source. And this annotation is now attached to that field and will carry over into the data set and even into the model. As we hover over this field, we're going to see it as a little tooltip. So that's also useful when you're working with data sets that other people may have created, and the fields may have confusing names. You can come in and provide a much more detailed description. All right, so with that, let's go ahead and configure a data set. And as I'm configuring the data set, I'm going to go ahead and remove this account field. The account field is specific to each customer and is unlikely to provide any useful insight, so I'll just take that out, and we will create the data set. Now, our data set creation process was unfortunately, or maybe fortunately if you want to look at it that way, very fast in this case, but we actually use a streaming algorithm that goes over the data in one pass and shows results in real time. So if this had been a much larger job, we would actually see these histograms building in real time, which is nice because you get feedback immediately. And what we get here again, the features are listed as rows, and we have a nice summary of each feature, the number of instances in the database for those features, and whether or not they had any missing fields or fields that were in error. And of course, for each one, we get a nice little histogram. So the area code, we see there are 3 different categories and the count for each. And for the fields that have a distribution, we get a little univariate summary analysis. Also, if we hover over here, again, you'll see there's the annotation that we added in the source. All right, now later in this walkthrough, we want to create an evaluation, which is a bit of a problem because in order to do an evaluation properly, we need to train the model with one set of data and then test it with a different set of data. And of course, in this example, we only have one data set. So we're going to solve this by splitting the data set into 2, which we'll do with this one-click training and test set. And if we go back out to the data set list, what you'll see is here was the original data set, and we now have 2 new ones. So we have a set labeled test, which has 20% of the data randomly selected, and we have the remaining 80% in a new data set labeled as the training set. So we're going to build the model from the training set. We'll go into configure model. And now typically what you would need to do is, the most important thing you need to do is pick your objective, which of course is the field we want to predict. You'll notice that it's automatically picked churn, Now, how did that happen? Well, that's because if we look at the source, churn is the very last column. And we automatically detect or automatically take the last column as the default objective. Which, of course, if that wasn't, or if you wanted to just play with this and try predicting something else, all you need to do is set the objective here. So let's go ahead and create the model. And again, we use a streaming algorithm to build the tree. So as soon as the first split is detected, we actually start displaying the tree, and you can see the updates in real time. And now our model is built. So let's just quickly describe the tree view. The root node is what the model, or what BigML has chosen as the most important criterion for determining the outcome of the prediction, which in this case came out to be the total day charge. And each one of these branches coming out of that root node is, of course, a decision to be made for that variable. So flowing to the left is a day charge less than 44.81, and flowing to the right is greater than 44.81. And the relative widths of these branches is the number of instances. So you can see on the left we have 93% of the data going that way, and on the right we only have 6% of the data. So that's why the one on the left is much thicker, of course. And as we go down the tree, we have the next question on this side, which is the number of voicemail messages. And again, you can see the tooltip from the annotation that we added. And the green nodes are endpoints where the model has enough information to make a definitive prediction. In this case, we see a prediction of churn being true with a confidence of 95%. All right. And we have some additional filters, as trees could be, of course, very wide, and we'll always try to display them in this nice rendered view, which is why some of these nodes are dashed. You can actually zoom in on these. There are sometimes nodes that are hiding. But we also have filters, so if you're only interested in customers who are churning, you can now look at this tree, and all these leaf nodes are all predictions of true. You can also filter out by confidence, so if we only want to see things that were very confident predictions, or maybe we only want to see not so confident predictions, you can do that as well. Coming back to our sunburst view, which I mentioned earlier, I like to describe this as taking that tree view we were just looking at and rotating it so you're looking down from above. So now that root node becomes the center of this sunburst view, and each concentric ring is a split, and the length of this ring is proportional to the number of instances in that particular decision. So you can see this ring that I'm highlighting here is the total day charge of less than 44.81. Again, that was 93% of the data, so it's a much longer arc. And this much shorter arc is the day charge of greater than 44.81 and only has 6% of the data, so a much shorter arc. Now this view right now is colored by confidence, bright green meaning highly confident parts of the tree, tending towards red being low confidence. And so what you get in this view is a very easy way to see the entire tree all at once, the regions that are very confident, that's all the bright green, and of course the area where there's a lot of decisions being made, there's a lot of going back and forth. And we can also color this by the actual predicted value. So we have dark blue, in this case, is a prediction of false, and light blue is a prediction of true. And so again, you can see this entire region of the tree is being all predicted with false churn. And as we drill down in this section of the tree, it's very easy to see the rules that are leading to this prediction of churn being true. All right, so let's, of course, returning to the other advantage of decision trees is that we can download them in an actionable format. We make that very easy to do with this download button that's right here. And these are the formats that we currently support. So if I click on Python, I'll actually get this model that we were just looking at expressed literally as a Python function. So I could cut and paste this into my Python interpreter, and I could make predictions for that model we just built. I could also do that for Ruby, Objective-C, C#, etc. And I'm going to go ahead and call another one of our new features, which is this Microsoft Excel. So if we click here, and we'll get a link that we can use to download this model. And what we have now is a view of this model in Excel. This is what we get is we can make predictions on this model right here. So we can put in, this is area code 415, number of voicemail messages 54. Maybe they made 34 day calls, and just with that data alone, we're seeing a prediction of customer churn false with a confidence of 83%. We also provide some additional tabs. There's a summary of the model properties that we provide, a summary of the model fields, and there's actually a form here where you can make multiple predictions. So this is a very cool new feature that has been asked for extensively. Okay. There we go. So that. Coming back to this, I want to go ahead and call out another one of our new features, which is secret sharing with a secret link. Okay, so previously you could share a model, so maybe you've built something that you'd like to show to other people, and we provided the ability before using our gallery. The disadvantage to using the gallery is that, of course, it's available to the entire world. So now, just by flipping this little switch right here, you'll get this automatically generated link that you can use. Whoever you give this link to will be able to access the model even if they don't have a BigML account. Theoretically, I can share that with you. There we go. All right, so let's go ahead and move into the evaluation of this model. Now remember, we held out 20% of the data, and all we need to do is come into here and choose the evaluate mode. And because we did the one-click training and test split, we automatically have the interface automatically picks up that we're more than likely interested in using the test set to do the evaluation. So all I need to do from this screen is hit the button to actually make it go. And of course, what it just did is it went through that test set and ran a prediction through the model for each instance and then compared it to the known actual value. And then you get a nice display here of your traditional machine learning metrics: accuracy, precision, recall, the F measure, and the phi. And with a couple of clicks, we can compare this to mode-based and random. Mode-based being you just pick the most common prediction. And so you definitely want to see your model doing better than that, at least, and we are in this case. All right, and another new feature is that, of course, in computing these metrics, we've generated a confusion matrix, but previously you couldn't see it. We've actually added that to our interface, so you can click here. You can actually see a table that shows you a summary of the true and false positives and negatives, and this will work for up to 5 by 5. All right, so let's come back to the model for a second, and let's move into the last step of the workflow, which is our predictions. So we through the web interface, we provide two ways to make predictions. One is we'll automatically generate a form, so categoricals become select boxes and numeric types become sliders, and we can just dial up a new instance and have the model predict an outcome for us. And in this case, we're predicting churn false with a 90% confidence. We also provide this prediction that is question by question, and this is essentially navigating the tree for you. So it'll ask you the first question in the tree, and then the next question in the tree, etc. So we're basically descending the branches for you, and at each step, we show you the partial prediction ahead of time. All right, so that's the demo of the BigML workflow. So there are quite a few features that we did not discuss, like ensembles, because what we want to do now is show our new features for the fall 2013 release. We've already seen 4 of them, so here is just a quick recap of those. We showed the inline field editing, which allows you to annotate features. We showed secret links for sharing models privately. We showed you the new confusion matrix and the Excel model export. Now here are 3 more of the features in our fall 2013 release. So the first is the multi-label classification. Now, BigML's decision trees support both regression and classification models. That is, a model can predict a real number or an item from a list of possible values. With multi-label classification, you can now predict for a single instance a list of values. In this example, perhaps we're predicting the set of subjects that a student might be interested in studying. Please note that this feature is currently only available through BigMLer, which is our Python-based command line tool. Next, we have the BigML Predict server. What does it do? It makes predictions fast, really fast. It's the perfect solution when you need to score millions or more instances or make near real-time predictions for an integrated application. Let's take a closer look at how that works. Here we can imagine you have an application that's using BigML to make predictions. You simply deploy the predict server in your own cloud account or VPC, and then tell it what models and ensembles to download from BigML. Then you simply change your application to use the predict server for predictions. It's that easy. And the low latency in-memory write-nothing predictions are super fast and scalable. In fact, the performance automatically scales with the number of CPUs in the predict server instance. And I'll share a quote from an actual customer. When we set him up with a predict server, he'd been using our production to score instances for a competition, and he sent back an email saying, this is a quote, "Crikey, that's fast." And finally, our brand new machine learning algorithm is text analysis. Now this feature is very exciting for us, and we've been playing with it night and day, so I'm excited to talk about it. Previously, when BigML encountered a text field in your data source, it was silently ignored. Now, however, you can enable text analysis and begin gaining insight from arbitrary text fields like emails, quotes, tweets, etc. So let's take a closer look at how this works. When you upload a source, BigML takes a quick peek and automatically determines the type of each field. The types that BigML recognizes are numerical, like integers and floats, categorical, list of things like true, false, red, green, blue, datetime, and this one is a bit different. When BigML sees a datetime field, it automatically creates new fields representing the year, month, day of week, hour, and minute of each timestamp. In a similar way, when BigML sees a text field, it creates new hidden features that relate to the frequencies of certain words. So as an example, and please keep in mind this is just an example, it won't necessarily perform exactly this way with this quote. So consider this quote. The occurrences of the word greatness would be reduced to the stem word great. And stop words like be, not, and are, which don't offer sufficient discrimination, might be ignored. In a similar way, words that do not occur frequently enough may be ignored, leaving a list of words from the text which are likely to be useful. And the frequency of these words in each instance is then added as a hidden feature of the source. All right, so let's see this in action. To demonstrate, I'm actually going to use a data set from Kaggle, which is the Stumble Upon competition. And in this competition, the idea is to build a classifier which can separate websites or distinguish between websites that are evergreen, that is, they are relevant for a longer period of time, or ephemeral, they're seasonal or only interesting for a short period of time. And in the case of the data set, a 1 means that the website content has an evergreen, and a 0 is it's not. It's relevant only for a short period of time. All right. So I'll just real quick show you, this is the actual Stumble Upon website where you can download the data. And I'm not actually going to do any massaging of the data. I'm just going to take this training file, which is in a CSV format, which we already understand very well, and upload this directly into BigML and analyze it completely in the web UI. In the interest of expediency, since this is a 20 meg file, it takes a couple of minutes to build the model. I'm actually going to cheat a little bit. I built it ahead of time, but if I hadn't told you, you might not have noticed. So if we switch over to here, this is the source, which I already have uploaded. And we can go into the source viewer, and I can just briefly describe what some of these fields are, so you can see the text analysis in action. So the primary text field, it turns out, of primary interest is this field called the boilerplate. And what they provide in that field is a little JSON document that has the title and the contents of the website. And then there's some other categoricals, like this alchemy category, business, recreation, health. And there's some numeric values. There's one that I like, which is the number of spelling mistakes, spelling errors ratio, and a few other fields. So here we have a data set that has a pretty good mix of categorical, numerical, and now these text fields. And I'm not actually going to change anything in here, but let me show you how the text configuration works. You have these little gear icons here for this text field, and if I click there, you can see that the language has been already chosen as English, but of course you could override that, and those are the languages that we support currently. It's easy to add new languages, so I would expect to see more in the future. You can control the tokenization. So this is something that we were playing with in a data set the other day. We had a data set that had city names, and we wanted to treat it as a text field. And of course, some city names have spaces in them, like San Francisco or San Diego. And by switching this to full terms only, it will still analyze this text field, but will keep the fields together. It won't split them on spaces. Of course, you can also tell it to use only tokens, or the default is both. You can control the use of stop words. So that was the, and, be, those kinds of common words. The default is to not use them. You can control stemming. So this is, does, doesn't, and all the variations of the word do would become the word do. And of course, there's a case-insensitive feature. If I wanted to change something here, I would just click one of those and save, and it would change. But let's go ahead and pop over to the dataset view. So this looks somewhat like before, except that we have this additional feature of the text fields. And we get, of course, a histogram showing common tokens in that text field. And we also get this really nice tag cloud, which gives you a very visual representation of what kinds of tokens were discovered in that text field and the relative frequency of each text field. All right, and let's switch over to the model view. So here's our tree, and I'll just go ahead and call out a few things. The root node turns out, in fact, to be the boilerplate, which is the text field. And flowing to the right is whether or not that the boilerplate contains the word recipe, and flowing to the left, of course, does not contain recipe. And this makes intuitive sense because looking at the tag cloud, recipe, as you may recall, was right there in the middle of the cloud. It was a word that occurred very often. And if we descend all the way down here, then we have, just an example path. There's various tokens that are occurring in this particular branch, and we are predicting that with these criteria, that the boilerplate contains recipe, that the boilerplate contains salt all the way down, then this will more than likely be an Evergreen website with a confidence of 91%. Now, there's quite a lot of playing you can do with this, and I actually had a hard time choosing the data set, but I like this one because it was really easy to see what was going on, especially in the sunburst view, where now you get this, you can see right away there's this bright green area over here, and of course this also is the boilerplate containing the keyword recipe. And you can see over here it's slightly less green. There's a lot more decisions that are being made as you descend there, and down here we have quite a bit of red, so this could be something interesting to look at down here as well. All right. And so with that, I'm going to go ahead and switch back over to Andrew to wrap up the webinar.
Thanks, Paul. That was great work, and I think the demos really showed the full set of BigML's capabilities. So to recap, I think we showed to you today that BigML is the only cloud-based tool that provides easy-to-use machine learning on diverse data types. Right? So the addition of the text analysis really expands your capabilities and sets BigML further apart from other tools in the marketplace. And we're very excited about today's release. It's the most significant step forward that the company's made since we went live late last year. And again, it involves the text analysis, multi-label classifications, the exciting new Predict server, the Excel export, and many, many other features and updates, which you'll see as you work through your own predictive modeling projects in BigML. So, Paul, if you can move to the next slide. The last message here is to get started today. One of the cool things about all these updates is that they apply immediately to all of your existing resources, all your existing data sources. So all of your pre-existing data sets that had text that couldn't be factored in before, you now can factor text into your predictive models. To encourage your usage, we're going to provide you with a discounted subscription offer. So if you enter in the coupon code webinar25, when it comes time to sign up for a subscription, you'll get a 25% discount on the first term. In addition, this is our first webinar we've ever held, and it's been great to see such strong turnout. We'll be doing this more often in the future, both this kind of formal webinar, but also more casual Google Hangouts. So if you visit our updated website, you'll see a new training page that has links to the upcoming Hangouts. And those are great opportunities for you to bring your machine learning challenges into our team. We'll be there and we'll answer whatever questions you bring our way. Lastly, if you have any questions or feedback, please send them to info@bigml.com or to support@bigml.com. Finally, please follow us on Twitter. So with that, I think we're going to wrap up. If you have any added questions, please email us again at info@bigml.com. And thank you again for joining today's webinar.